Hello, and welcome to Android Developers Backstage. I'm Tor Norby from the Android Studio team.
I'm Romain from the Android Toolkit team.
And I'm Aurimas. I am from AndroidX team.
All right, so we're talking about AndroidX today.
Yes, but something a bit more specific than that, right?
That's right.
So, Tor, I mean, you've been waiting for this.
I'm
got
actually
rid of
curious.
Chet to be able to talk
why
about
did we
this.
invite Aurimas?
So, Aurimas, what are we going to talk about today?
Well, I think we're going to share a little bit about how AndroidX has been doing work with Gradle and how we collaborated with AGP and Android Studio, and just in general, like how we are affecting the ecosystem for app developers out there.
Yeah, so AndroidX is kind of a super user, I would say, of the Gradle build system. So, frequent requests, frequent complaints, but also, I think pushing our team to keep advancing the build system forward.
Yeah, for our listeners, could you describe maybe the scope of AndroidX in terms of Gradle and build system? How many modules do we have? How big is that project really?
Yeah, that's a good question. I think right now we're at about maybe 800 Gradle modules in there. I would say maybe 2/3 of them are Android, and then the rest of them are Kotlin multi-platform, Java. And then we kind of use AGP, Kotlin Gradle plugin, and a bunch of other tools to kind of build on top of Gradle and publish all of that. So all of our workflow is in Gradle. We are not using any other build systems outside of it. And we use it to kind of do our day-to-day as well as CI and publish and kind of really dogfooding the experience that the Android Gradle plugin provides.
So not being a Gradle expert, you said 800 modules. That sounds like a lot. I've heard of external apps having more than that, in the few thousands, but it sounds like this makes it one of a large project, at least for Gradle, right?
Oh, for sure. I think most kind of hobby apps are in a dozen and sometimes even less in size. And so we're really kind of, in some ways, testing out what happens when you do have something that large and, how does it affect Studio? How does it affect the build? All of that. We're kind of getting pretty realistic image of what it looks like to, really work on that many libraries.
So with 800 modules, I'm sure that the configuration caching feature was something that was quite meaningful.
That's right. It actually made quite a big difference. I think even before configuration caching, we felt very strongly that we want to make sure that our configuration phase is just fast in general. So we spent many hours optimizing, filing bugs to Gradle, to AGP, and stuff like that, just kind of making sure that it's as good as it is. I think it doesn't help that it is a single-threaded operation today, and so it means that as you add more projects, it scales linearly. So every new project adds that much time. So jumping to configuration cache was a big thing, and so we actually adopted it way before it became stable. We were one of the early adopters.
I don't think it's stable yet, as far as I understand.
It is stable already.
In which version of Gradle /AGP?
Gradle 8.1 shipped configuration cache stable, but it's not default on. So it's something you have to
that's
choose
what I
to
was
turn
thinking
on.
of. Okay, yeah, so it's not on by default. It is stable, but not on by default. So that's the first tip of this podcast is, hey, make sure you turn this on. It's going to make a difference, especially if you have more than a couple of modules or not a lot of tasks.
And I think one thing that may be worth mentioning is what it does. The configuration phase for those who maybe don't really know that much is the phase that takes all of your build files and generates a list of task graph that you can then execute. And then configuration phase generally is fairly slow because it has to parse all your files, execute all of the Gradle plugins, kind of do all the work. But normally when you kind of iterate on your build, you actually don't change build files, you change classes and you do kind of the work outside of the build system. And so redoing that work over and over again, it's problematic. And so now that's what you kind of want to do is that you just want to serialize that to disk and then you can load it from disk. And so if you change a single Kotlin file, the only thing it does, it just starts executing and starts compiling right away as opposed to calculating how should you be compiling.
So you mentioned that it builds and caches the task graph. So I imagine the tasks themselves are potentially the issue for configuration caching, right? The tasks have to be cacheable. So what does that entail? Because if you write a custom task in your project, you may, I assume, break the caching. How do you fix that?
Romain did that because I remember a couple of years ago, I was doing a demo for I.O. and I had configuration caching on, and then I wanted to include some nice WYSI graphics from Romain, and so it was using some sort of texture map, and you'd written a task which basically was extracting, I don't know, something from the texture into the format Android needs, and your task was not cacheable. And I didn't know enough about Gradle how to turn it cacheable either. So I was like, if I do this, I can't have configuration
If I
caching.
remember correctly, it was complicated because it was a task with that had multiple outputs from a single input.
Yeah.
And I think that's not something.
It's a no-no.
In build system, I know in the past, like I've had issues with tasks like this. But anyway, so yeah, if you enable configuration caching and you have a task that's not compatible, like why is it not compatible and what do you do about it?
So I think to kind of get started, I think luckily for most app developers out there, the major plugins have already done the work to make it configuration cache compatible. So AGP, Kotlin Gradle plugin, a lot of core Gradle stuff is already compatible. So unless you've written your custom stuff, you should just work. And so for what does it mean to make it work? It really depends on like how extensive your stuff is. But the main idea is you have to be able to serialize the inputs to the task in a way that you can resume the work without assuming any static state, kind of having a very clear picture of what you're using. So, I mean, an example, when you're using configuration cache enabled, you're not allowed to access the project object from the task. And the reason it's dangerous is because you could access anything and there could be like all of this ephemeral state that you would use. And that would lead to a non-predictable result if you serialize and then deserialize. So, you turn it on, Gradle will start warning you and it will generate a report and kind of will tell you all the things you're violating. I would say they catch like 99% of the problems. And there's some really kind of like weird edge cases where maybe you have some stuff that works some of the time, but not other times. But generally, the report will come and it'll be like, don't use project here. Declare input here, have an output declared here, and then it kind of helps you with, the process. And it also will nudge you towards like, oh, this lambda that you pass in as an input to the task is not serializable, make it serializable, or, things like that.
So you just mentioned input and output. So I imagine that for the task graph to work properly, every task needs to be able to declare statically or to declare like the list of inputs and outputs. Is that challenging to do? Like, does that cause these issues sometimes, or? Because I can imagine it's difficult. Like I said, like for instance, if you have an executable that can generate multiple files, like is there a way to define that in Gradle to say like from this input I'll have multiple outputs?
Yeah, I would say yeah. The answer is yes. In general, the way you would model it for that specific thing, you can probably say I have an output of a directory, and that way then anything you write to that directory is your output. And that way it's still modeled correctly. Gradle will detect if you delete that directory and you will know that it needs to rerun it. If you modify something within that thing similarly. And it even will detect if you share the same output directory for multiple tasks and be like, now you're entering danger territory because you might be overriding each other's inputs and stuff. So I would say as far as we know, you can model most of the things unless you're doing some sort of like analytics reporting type of stuff. And I think Gradle is still kind of figuring out what should that look like in this world of configuration caching. Like if you want to detect every time someone runs a task, like what does that mean? I think AGP, Android Gradle plugin, has come up with some ways of like storing stuff in protos and stuff, and then sharing for people who have agreed to share the stats through Studio. So there's like ways to go about it, but it makes it like slightly more complicated now that you don't have that phase that runs every time.
Right.
Here we have the build analyzer in Studio, which. Well, for one thing, it suggests you try configuration caching, and it kind of walks you through the flow of trying it. The other thing it does is it actually does look for cases where you are having multiple tasks point to the same output and kind of try to help debug those things, which are going to be bad. Speaking of caching, there's also the local cache and the remote cache, and I believe that you're doing something kind of interesting with remote caching in AndroidX. Can you talk a bit about that?
Yeah, so now we're entering a territory of build caching, which is different from configuration caching. I believe that's what you're alluding. Mm-hmm. And then this is specifically, if you run a task and you don't have anything in your build directory, it is able to reuse the work you did before.
Well, that's the local cache. And the remote cache is if someone else has done the build, right?
That's right. So kind of Gradle out of the box supports ability to you kind of use pull-push model for cache entries. The way it works, you have a key that is essentially a hash of all of the inputs, and then you have to return a blob that is, the result of that task, and then it can take it, deserialize it, and put it kind of where it's expected. Both the local and remote cache are kind of off by default in Gradle, so it's something you want to choose to enable. Local cache, I think everyone should have on, and if they don't, you should really, that'd be the first thing I would do.
Why is that off by default? Yeah.
No, I was going to ask, why is it useful? Because I use it. for demos, right? Because it's very useful for that. Like, okay, I don't want to rebuild something that I want to be fast, because it's not the point of the demo isn't to be fast for building. But how often am I trying to build something I've already done before? Isn't that just kind of like wasting disk space and not really saving time?
It depends on your use case. So, for example, if you're switching branches a lot, you might hit that case a lot where, you're doing some work, then you go back, do some other work, but then the previous work is useful if you want to go switch back to the previous branch. So for local cache, that can be very helpful. Or if you want to, do some sort of iteration on, like you keep going back and forth on something that you want to test, like redoing the same work, it can, be a wasteful, opportunity there. I think the reason Gradle doesn't turn it on by default, it comes with a cost, as you were saying, right? You have to serialize these objects and write them to disk per system, and then you have to deserialize and load them. And so it comes at a cost. But I think for most projects, it's well worth it. And it also exercises the thing that you would see in a remote cache as well. So that way you're kind of getting the experience. Like if you went and messed up some of your inputs and outputs for tasks, it will become much more apparent because you have a local cache on, and so you'll see the same problems.
I found local caches are also good when you want to test that your clean build works, because it's a good way to exercise, your plugins and your tasks and whatever, making sure they clean everything. But then when you need to rebuild, it just fetches from the cache.
So I'm hearing it's good because you have more pain.
More pain? What?
Well, it's shifting left, right? Like you learned about your pain sooner.
Yeah.
I mean, that reminds me of configuration caching again, where like, when I was new to Gradle and I was doing, okay, let me clean. And it's like, it's building a configuration. Like I'm waiting for it to compute a task graph so that it can clean. I was like, can you just delete all the generated files? I didn't understand.
Just nuke the build directory.
Yeah. And I sometimes do that.
Yeah.
Yeah.
So you mentioned, so that was local caching. So remote caching, how does that work? Is that something that's supported out of the box, or is that something you need to like somehow implement or use plugins for that?
Yeah, that's right. So for the remote cache, you need a server component, obviously, to have a thing that stores these bits. I think the standard, the thing that Gradle suggests is using their Gradle Enterprise, but it is a paid solution that not everyone might want to opt in. I think there's also potentially concerns for some about it being closed source, so you don't necessarily know what you're running and like where do your bits go. I'm sure, legally, I'm sure that they're doing the right thing, but like there might be some uncomfort for people who want to use stuff that's fully open source. For us, what we decided to do is that we have a pretty easy way to talk to Google Cloud Platform buckets. So just storing stuff in Google Cloud buckets, we are able to put results there and restore from there. So Gradle, being a very flexible system, actually allows you to have any arbitrary backend that you want to talk to. And so what we ended up doing is we wrote a plugin that you apply to your project, and that allows you to talk to GCP and store the blobs the same way it does in local cache. You take the inputs of the tasks, and then you get the results back, or you don't, depending if there's a cache hit or not. And that allowed us to kind of very quickly and like fully kind of open source do the work that we wanted to get done, and it had massive effects on our performance, because now we're able to skip a lot of work. Like when someone is working on one library and they haven't changed like 400 other projects, we don't rebuild them. We just fetch them from the cache, and that just gives you the much faster pre-submit times, and then you're able to kind of iterate much faster. Same with like local runs as well.
I was also assuming that me as a user, right? If you have a continuous build and it's always building head, then it's very high likelihood that all my upstream dependencies that I'm building locally will just be pulled from the CI.
That's right. And we do exactly that. So we use the post-submit builds to fill the cache, and then everyone else just pulls. They do read-only. And that way we're kind of certain that, there's no like cache poisoning or anything like that. And stuff that has been reviewed and has been landed, then only then the cache is filled. And that, allows it. So by the time someone fetches the code, they're usually a CI has already finished building by then. So if you run a task and you've not modified anything, you should have close to 100% cache hit, except for like some special tasks that are faster to run locally, like zip tasks or.
Right. I was going to ask about that. Like, are there, because network, obviously, if you're inside Google and you have like a really good network connection, it's going to be really fast. But are there situations where it's just faster to just run the task locally, even compiling code?
Yes. And specifically, currently, the Gradle guidance is anything that is a packaging task, so a zip or non-compressive jar or things like that you're essentially moving stuff around. those tasks tend to be a lot faster to do locally or even like extracting stuff from a zip archive. So those they suggest you mark do not cache, and essentially that means it just will do it locally, and then it tends to be a lot faster. I think maybe there's a little bit of kind of a design choice for Gradle. Unlike some other build systems, there is no race. So some build systems choose to do run locally and then try to fetch remote, and whichever one wins is the one that goes. Gradle currently does not support that, so you essentially have to explicitly choose: do you want to restore or you don't? I think to help that a little bit, one of the things that we do is we host our buckets distributed across North America. So people who work in Boston actually talk to a different backend of like the buckets. And so that way the fetch time is a lot slower, right? You don't want to go across the whole country because that's many, it's hundreds of milliseconds of fetching time.
And so to talk to the GCP buckets, is that something that you and your team had to write? Or is that something that Gradle has facilities to talk to GCP out of the box and there's minimal integration?
Yeah, so they don't provide anything to do that. The thing that works out of the box is Gradle Enterprise plugin, as I mentioned. Okay. So you turn that on, apply a single plugin, and then enter the URL of the Gradle Enterprise instance, and you can use it that way. For us, we wrote our own plugin, but it's a fairly thin wrapper around Google Cloud Platform library. Essentially, we handle the credentials and auth, and then we send these things and fetch them. And so it's a fairly simple, I would say a couple of hundred or a couple of thousand line, library.
And I imagine it lives in the AndroidX source tree. So if someone wanted to do the same thing, they could use that as a starting base for their own solution.
And in fact, we did that. So someone external wanted to use AWS buckets to store the results. And the way we wrote it, it was kind of abstracted of what backend you talk to. So they essentially were able to add ability to just talk to AWS instead, and they're using AWS libraries to do the talking. So now this plugin actually supports both modes. And if someone came a third system and they want to store it, and yet another thing, it would be fairly trivial for us to add as long as you're able to kind of fetch for a given SHA. Mm-hmm. Now you're able to add it and extend.
What's the status of remote cache support for the AGP tasks? Are they all supported at this point?
I would say majority are, yes. I think for a long time, lint, your favorite, was a thing that did not. And I think that caused us a fair bit of grief when we enabled the caching and we realized actually we're still spending a lot of time lint analyzing. But luckily, Scott on AGP team did amazing work of kind of really declaring the inputs and outputs. And it's kind of like the stuff you were talking about. Sometimes it's non-trivial to understand what is an input, especially for lint, that it uses a lot of hints.
It wants to depend on everything, your build scripts, your resources, your source files, your properties files. It tries to analyze everything, and that makes declaring the inputs hard.
Yeah, and it's finally sorted and managed. So if you run lint and it's already been run, nothing happens. It just restores the analysis results, and then you're kind of done there. So I think from AGP side, it's pretty good there already. And I would say some of the other big plugins like Kotlin also do the same thing, except when you enter the area of Kotlin multi-platform, there's some tasks that are still need to work.
So the output of the build is in the remote cache. Can the task graph itself be in the remote cache, or is that something you always need to run locally?
That's a good question. Today, the way it is written, it is not remote. It's not possible to restore a configuration cache from a remote location. And the main reason is they use a lot of local paths when they serialize. So if they want to know where is the jar for your execution of a test task, they currently do a lot of absolute paths and stuff like that. They have goals. I don't know if they have announced any actual specific plans, but they do have goals for configuration cache to be restorable. So that way, when it runs in CI and you run locally, you would be able to. I think it is questionable of how much gains you're going to have out of it, because usually configuration phase, depending how well you do, ours was maybe 60 seconds. So the savings is the very first run, and then the next one it's already hitting that. So there's a limited gain, but there are
there's something appealing about you do your checkout and then immediately you have a build that's ready to go.
That's right. I think that would be nice, and I hope a Gradle gets there.
So you mentioned before, so configuration caching, remote caching, obviously those are major optimizations, but you mentioned other types of optimizations before we did all those things. So what kind of optimizations were you talking about? How do you optimize a task, right? Obviously, if you invoke an external dependency like APT2, you're not going to optimize APT2. So what do you do in the tasks themselves to get them to run faster?
So I think there's two aspects there. There is the configuring of tasks that we wanted to optimize, and there's optimizing for the execution of task itself. So I think we've spent a fair bit of time on a configuration phase before configuration cache, because we wanted to make sure that when you run and try to configure 800 projects, it doesn't actually take forever for you to do that. And the kind of way you can do it is essentially just running a Java profiler. So we run configuration phase, a dozen of times, and we kind of take traces and we look at your kit and just do like a regular JVM tracing. And like an example of the kind of things we found is, for example, lint has an input of package.xml to know which version of AAPT it is running, so it can do certain analysis correctly. And we found that it was doing it eagerly. It was trying to read that XML file, resolve it during the configuration phase, but it's not necessarily like needed. You can do it at the time you run the task. So taking that work and shifting it to a task execution, that means when you run a build, you're no longer trying to read and parse and execute that XML file, and it's shifted only when you're running the task. Then you do the work. So we did a lot of that kind of shifting the work to be more lazy. So taking stuff that is maybe like an active I/O read, and I/O reads are especially bad because when you have 800 of them, like you bog down that this disk very quickly. So like shifting more and more of that.
And that's
really
800
helps.
because you're running the build in parallel. So all 800 of your modules are like, in theory, competing. Okay.
Yeah. So it's it's an important thing to kind of like make sure that you don't overwhelm the I/O. It's kind of like at that point, it's like any Java project. You want to make sure that you're kind of like using your resources well.
Traditional optimizations. But there was nothing specific really to Gradle or building. It's more like we run code, therefore we need to optimize the code, whatever that means.
I think that's the high level true. I think where it gets more tricky is like some code you don't own. Like there's some code that's like Gradle runs and you're like, why on earth is it doing 20 seconds of this? And sometimes that results in real bugs. So for us, for example, one good example was Gradle was using exceptions for control flow. So they're throwing an exception anytime you had I'm trying to remember exactly the details. I believe it was when it was trying to resolve dependencies. If it couldn't resolve it, it would throw an exception and then catch it in a different place. And in our build, because we had 800 modules, we were throwing tens of thousands of these exceptions. And then we reported, like we did a trace, we found that, it's really weird. That's a lot of objects being created. And Gradle stack traces tend to be 250 or so.
Building a stack trace is expensive. It's funny because I remember the early days of Java, and I've never measured it, but I never believed it. There was this performance myth that, in Java, how every time you access an array, it does a bound check. So there were folks who believed that you should do a for loop where, because the bound check is done for you, you should not check for, when you say I equals 0, I less than length. It's like, don't do I less than length. Just write an infinite loop and wait for an array index out of bound exception. I was like, but an exception is way more expensive than doing your bound check every time. But some people really believe that this was the right way to optimize the code.
And I think for us, when we reported to the Gradle, they're like, oh yeah, we thought this happens only once in a while. But I think we were in such a setup that caused this to be a very, very common exception. And I think for us, it's something like 10 seconds shaved off of the configuration time. It was like drastic improvements when they moved to a new version that did not use exceptions.
I mean, it's interesting because what you're describing is exactly what happens to us with some of our own AndroidX libraries, right? Like an app is going to use Compose, and maybe they'll use way more composables than we thought an app would use. And they're not doing anything wrong. It's just our own expectations were misplaced, and it's on us to optimize it.
640K ought to be enough for everybody, right?
Yes, something like that.
Yeah, and I think in that space, I think that's where it becomes interesting that our team has so many different layers of where we work, and sometimes you can actually cross-share knowledge. So like Chris Craig, who's been spending a lot of time on optimizing stuff in AndroidX library side, there's definitely some similar strategies of like, where are we spending time? Like, how do you look at traces? Like, how do you make sure that you kind of benchmark stuff properly? Like, you running it on a phone, in some ways, is not super different on, desktop. So like, having some of that shared knowledge can be really, really helpful.
I mean, I imagine that you have a very different environment, right? You're going to have Art versus the hotspot VM, and the garbage collectors are very different. Like the performance profile, like you're not going to focus on the same things exactly.
For sure.
But I assume the workflows are very similar.
And even generating ideas, like for example, in Android, we've done a lot of work to make very lightweight tracing simple, right? And then you can like run it with very minimal overhead. And right now, Gradle doesn't actually have a way to do that kind of lightweight tracing, but we could, right? Like a lot of the libraries that Google has written, you can actually have these trace points that you could later generate, a Chrome tracer or something similar.
I mean, honestly, one of the things I would love about that, one of the reasons I love Perfetto or Systrace or however you want to call it on Android is that it's also a very good way to understand what happens, right? In what order things happen. So for something like Gradle, like someone like me, like I have to deal with Gradle from time to time when I write code, which is not very often. I'm not a build expert. I'm not a build engineer. And I would love to better understand, what happens under the hood, in what order. Because sometimes I'm just firing blind. I'm like, I'm going to, it's the +1, no, -1. Oh, guess it works.
Don't touch it.
Yeah, except it's with the build system, so it's a little more scary. But
no, it's true. It's hard. I think part of the problem why optimization is really difficult, you need a lot of specialist knowledge of what is okay. Like, so I think one example where we kind of hit is we use Gradle verification for dependencies to see if their signatures are matching what the publisher has said, to essentially make sure that the library actually comes from the source that they claim that they do. And one of the things that Gradle does, it needs to load all the signatures to do the validation against. And we're looking at these traces and we see like a ton of I/O, like thousands of calls to this key file. And like, it's really hard to know, like, is this intentional or is it a bug? And at the end of the day, spoiler alert, it was a bug where they were using a file I/O input stream and they were reading 1 byte at a time because we're using a library that doesn't use a buffered source.
Right.
And so that just caused thousands of I/O accesses for not a good reason. And like, even if you look at the same file where they were doing this reads, they forgot it in one place. Every other location was using a buffer stream, and then I was able to, decrease it tenfold, maybe even more. So it's just like, sometimes you don't even know, like, is this a bad behavior or not? And it takes kind of expertise and understanding of like, does this make sense? Does it not make sense? And I think for us, luckily, we're sitting in the building where I can go walk over to AGP team and be like, does this make sense? It looks suspicious to me.
Right. Well, and also, I mean, back to your original point, the fact that AndroidX is such a large Gradle project. I mean, obviously, we're not going to solve all the problems, right? But we do track some of the most recent versions of AGP and Gradle. So we do tend to run into a lot of those issues and performance problems, like maybe not first, but at least amongst the first. And so we have a chance to like help the community by, feeling the pain first and hopefully getting it fixed before someone else does.
Yeah, I would say like we've gotten even better over time. So I think, if I look back like 5 years ago, like there was no kind of integration between AGP and AndroidX. It was just, AGP does the work. They ship a library and their plugin, and then maybe, 2-3 weeks later, we try to upgrade, hit a bug. Then we wait another 2 weeks because a bug needs to be fixed. The fix maybe doesn't have all of the things. Then we wait again. And then like it's enough to have one bug where you're not able to upgrade anymore, right? So it was kind of causing a lot of friction. So one of the things that we ended up doing is right now, if you actually make a change to AndroidX or Android Gradle plugin, we actually run head against head. So we build Android Gradle plugin from scratch, and we build AndroidX from scratch, and we validate that configuration phase passes in that mode. So it allows us to make sure that there's no APIs being removed or behavior changed in a way that we didn't expect. And I think we prevented hundreds of kind of micro regressions that you might have had.
It's one giant post-submit test.
Exactly.
AndroidX. I mean, similarly, it's not quite Gradle, but we do use kind of like the latest studio. We're always on the Canary builds. And that's what we use for day-to-day development on AndroidX. So we run the latest and greatest on this massive project. So we also tend to run into some issues.
What? Exciting and tantalizing, problems.
Yes. But yeah, so again, like we try to like, I guess dog food is the term, right? As much as we can so that we can catch issues before they reach our users.
Yeah. And I think one of the things to note, especially on a build side, we also try to pick things that are kind of experimental or work in progress. So configuration cache was a good example where we, months before it was a thing that people could use, we were pushing all of the plugins in ecosystem to move forward. Like there was fixes in Kotlin Gradle plugin, there was fixes in Protobuf plugin, like various things that we used. Like we ended up nudging those teams of like, look, you got to fix this. Stable of configuration cache is coming soon. If you're not ready, your plugin is going to block someone from upgrading. So that kind of like eager adoption. And similarly, we often try out release candidates and even sometimes milestone releases of Gradle, which sometimes we catch things that would have been a massive pain for people.
I remember a couple of times where you had to revert one of those because we ran into issues.
Yeah.
I mean, it's one of those things I wish people would do more of that, because it's kind of sad when you finally get to stable and then people decide to try it and then you get the feedback.
Yeah,
You're
but
like,
it's also not their responsibility.
no,
right?
I understand. But it's
Like,
just one of those things where, it's unfortunate because then you have another 4 months, right, until the next stable when you have a chance to fix it.
that's why we try to do that. Obviously, we can't catch everything because, we're not going to do things in our build that don't make sense for our build. But hopefully, given the scope of AndroidX and the number of very different libraries we have, hopefully we exercise a lot.
And I think we're able to catch some really subtle things as well. Like our build, through kind of our experience, we found that there's certain things that we want to assert on top of what Gradle asserts. So an example, for example, is the output overlapping. By default, Gradle allows you to overlap task output directories if they're in different projects. But in our mind, that's still a massive foot gun. You run a task on one project and then the other, and then it causes, an overlap. And in fact, we hit some bugs like that where AGP made a change. It seemed reasonable to them at the time. I believe it was maybe CMake, where they were they were sharing outputs for debug and release tasks, and then they were putting it in the same directory. Would have shipped, and then someone would have had problematic issues, but then our CI caught it because we're like, okay, we want to do more assertions than Gradle does. And that allows us to kind of iterate and be like, oh, did you mean to do this? And often it's like, oh, I didn't think about that, right? And then that's the kind of stuff where we can kind of go and back and forth. And AGP, in fact, has a monitor for the build. And so when some of the stuff that is post-submit, they can go look back and be like, oh, did we intend to make lint behave in this way? An example we recently saw is R8 started printing out logs, and it started printing out logs as errors, in the terms of STD error. It doesn't fail to build, but it prints out stuff very spuriously. And we have assertion that any log that shows up in our build is actually within our allow list. We built a list of kind of code debt, I would say. And we try to make sure that no new things get added. And then now R8 starting to print new stuff we caught in our build because we're like, why on earth is this thing being printed? You're doing some sort of transform that is not useful to the user. We file a bug, and now R8 goes and moves it to info, and now it's not kind of bogging users down unnecessarily.
Yeah, or at least give us a quiet option so that we can suppress this output. Yeah, it's interesting because in our build system, so you mentioned CMake, so we do have some native code. So we do use CMake. You mentioned Kotlin multi-platform. We do a lot of things that many Gradle projects are not going to be doing. So hopefully there as well we catch on the fringe of the Gradle files we catch issues.
Yeah, I would say Kotlin multi-platform is maybe one example of that, where I think it's a project that's incubating, is not shipped stable there.
Yeah, it's still actively being worked on.
Yeah, and I think we definitely have inputs where they make one decision and then we end up kind of chatting and be like, oh, is this the best way to approach it? Because then you introduce, X, Y, Z. An example of that, Kotlin, the way they do source publishing, they actually smush all of the files for every single platform into one zip file.
Yeah.
But then they didn't think for what happens if you have a same file name? Which one wins? There's no warning. So we start seeing that kind of stuff and we're like, oh wait, let's pause. Should we not allow shared names of files? And then we can iterate with JetBrains to make sure that, that kind of plug-in work, by the time it ships stable, it'll be obvious. User will get warnings that make sense. They will able to kind of adopt and use it in the way they would want.
And sometimes it's also broader ecosystem problems that obviously, we can't necessarily solve. But I remember, you mentioned Kotlin multi-platform. So if you want to push your multi-platform library on Maven, Maven Central wants you to have source and Javadoc for every artifact. Does it make sense to have a Javadoc, zip file for your desktop or iOS version of your library? Maybe not. But then, I don't know if it's been fixed now, but I remember a couple of years ago you had to write a lot of custom Gradle code just to generate those extra Javadoc things, just because of Maven Central, right? Nobody else wanted those things. So yeah, it's a long road. It's gonna take a while. But
yeah, I think having static checks as part of the build is super interesting. And I know another thing that you do is checking signature files. I can't remember. Have we talked about Metalava on this podcast? I don't know if we have.
We can,
But, now's a good time, right? Because, I think that's one of the really important things for a library. The Android SDK as well, which is where it started. But, AndroidX basically is doing static checking of all your signature files. I think we even recently I heard that we've switched AGP over to using Metalava now, which is nice. So can you talk a bit more about what you're doing there?
Yeah, I mean, I think first maybe we should explain to people what is a signature file. So the thing that we really care about is that as users do library upgrades on purpose or through transitive dependencies, we want to make sure we don't break them through binary or sourcing compatibility. For us, we feel it's very important because we follow semantic versioning for our libraries, and having a binary breakage essentially means that you are now putting all of this in jeopardy where people can't upgrade easily.
And it's not just semantic versioning, but the entire workflow of AndroidX, our alpha, beta, RC, a lot of developers, I see sometimes that confusion, and it's on us to clarify it, but a lot of people think alpha means our library is not stable. That doesn't mean the code itself is not stable. It means our APIs are not finalized. They may change, and very likely they will. But so for us, it's all about the APIs.
Yeah, that's right. So we essentially want to track the API surface that we promised to developers to be unmodified, right? So there's...
or if modified, compatible.
That's right. It has to be evolved in a way that is compatible to, there's a Eclipse guide for evolving compatibility of APIs, and we essentially ported a lot of that and validated that we are following that for binary compatibility. And in fact, we sometimes go further and we try to make sure that we retain source compatibility as well, because we know it's costly when someone has to go and do migration.
Breaking source compatibility, we've done it, but it's usually the last resort, right? Like we really, really avoid doing it. But yeah, the binary compatibility is the one we do not want to break. Your app is deployed on Play Store, it should always work and needs to keep working.
And I think where it gets really kind of like not obvious, I think for people that are like, oh, like if I chose it, I should do the work to upgrade. But I think where it gets really tricky, you have a third-party library that you're pulling in, and that depends on AndroidX.core. If we go and remove a method that you use from AndroidX.core because the version gets bumped up, you're just going to crash at runtime, and you're not going to notice at all that's happening, right? So that's the kind of stuff we want to prevent and we want to avoid. So I think that's where we get to the thing that Tor is talking about, is a tool that he authored, and then later I took over, and now it's been passed on to yet another set of people, which allows us to use PSI and UAST, the machinery that IntelliJ uses to do analysis, to essentially build a picture of what is an API surface. And we take that API surface and we essentially store it in files in AndroidX, and we store it per version. So that allows us to make sure that, something that we ship stable, we will make sure it doesn't change in an incompatible way. But then it still allows us to remove alpha APIs because we know that the API surface is not finalized for it. So it gives us a really fine control over what is allowed. And similarly, we're also tracking experimental APIs. Like we want to make sure that the APIs are good, but experimental label means that they might change. And so we are allowing more flexibility for those type of APIs to be modified in a way that is breaking binary compatibility or source compatibility. And that's why there's kind of a accompanying lint check that will warn you like, oh, this is an API you're opting in. You have to say @opt-in, and then, kind of choose to pick that.
So short history lesson, but the concept of tracking the API, Android has been using that since before Android 1.0. It used to be a Python script that I think was just using regular expressions to parse your Java code. So obviously Metalava is way more advanced.
Well, it was, I think they switched to a Java doclet.
Yes.
And that was the state of the art until we decided we want to support Kotlin. And then a Java doclet was no longer an option. And so that's why, okay, if we're going to have the Android SDK be Kotlin friendly, we needed annotations, right? So you can insert nullability, and trying to do this to doclava was basically a non-starter, right? And that's why, like, okay, because it had no unit tests for one thing. So you can mess with this tool and you have no idea what you've done. So that's how Metalava was born. And then it turns out AndroidX kind of needed it anyway, and they wanted Kotlin. And so doing this analysis on Kotlin is trickier. And I'm not sure exactly where we are, but I think it's I think it's still capturing the Java view of Kotlin, if I'm not wrong.
It's mostly true. So it's capturing most of it is mostly the way that Java sees it, because that's usually how the binary compatibility is affected.
Plus the special hacks around like parameter names.
That's right. Yeah. So I think we also, model things like properties and stuff like that, because we also don't want to break Kotlin users unnecessarily. So it's kind of like a blend of Java and Kotlin. I think there's still more space we could grow in terms of supporting Kotlin more properly, especially when you enter a multi-platform world, when you have like expects actuals and things like that, or inline classes and stuff. We try to model a lot of this and try to track it, but I think it gets, as you said, is more and more difficult to represent it in a way that's unified across the Java and Kotlin users.
Parameter names in Kotlin is always the thing that gets me. It's so easy to forget that all your parameters names are basically public API in Kotlin.
And the nice thing is that Metalava tells you, right? And so I think one of the key values of Metalava and its predecessor, Doclava, is that it runs as part of, when you want to check in a CL, as part of the build, it'll actually update the signature files too. And so you'll break tests if you don't also update the signature file when you submit your code. So your code reviewers will see, oh, you changed the public signature here. Was this deliberate or not? Right?
Yeah.
Because sometimes you don't realize that method was public. I thought it was all private.
And in fact, we take it even further where for AndroidX, if you make a change to an API surface, we require a special type of review that we call it API review. And that means someone from a group that spend a fair amount of time looking at APIs has to come in and help you review and make sure how does it look like in the context of this API surface? Is it following the best practices? And kind of does the enforcement. And additionally, Metalava actually helps catch some of these kind of API design type of things. We have API lint, which essentially helps us do things like maybe we expect an executor in a certain types of calls because we want people to choose what thread they get a callback on. Or we want to make sure that the naming of getters is consistent with the setters. So we do a bunch of kind of like additional things that is not necessarily like required Java stuff, but it makes it nicer to kind of utilize. And it also speeds up the API review process because it also catches some of the very trivial things of like, if you have a builder and you have a setter on that builder, the object you return should have a getter for the thing you just set. So like, helping catch that stuff. And so people don't have to keep it in their brain of like, what are the rules I want to follow when I'm writing a new API? And instead they can focus off like, I want my API to be nice, right? You start there, and then everything else is kind of caught along the way.
It's the style check equivalent of APIs, right? Like a lot of people in CI make sure that they check that use the right number of spaces and stuff like that. Well, we do this for APIs because there's a lot of stuff that can be automated, like all those checks. And it's fantastic because some of those are super easy to you forget, right? Like you make a small mistake and it's nice that they're being caught automatically.
And this really was a Python script before Metalava. And,
and
one of the reasons why this is in Metalava as opposed to a lint check is that Metalava knows what is API and not. And in AndroidX, it's kind of easy to know because it's all library code, well, sort of. But in the platform, it's super hard because in the platform, there's all this magic with like comments that hides APIs and prunes the whole graph from the API surface.
The public modifier in the platform code does not mean it's a public API.
That's right. Whereas in AndroidX, I think that's probably closer to the truth.
Yeah.
In fact, to make you very happy, we actually got rid of add hide annotation or add hide java.comment tags in AndroidX. We no longer have any.
Oh, nice.
And the thing with Metalava, I've seen third-party libraries use it because they see the value. And it always makes me so happy when I see a GitHub where I recognize, the folder names and like, yes, they're tracking their APIs. And so if you're working on a library that you publish, like I highly recommend you do something like this. Either use Metalava or do your own. But because again, it's very easy to break APIs unknowingly. And maybe that's what you wanted to do, right? But it's good that you've done it.
Oh, for sure. I think it's one of those things like after you see it, it's like, duh, why wouldn't you have it, right?
Yeah.
It's one of those things. And I think as Tor was mentioning, Android Gradle plugin now has an API surface they promise to keep around. If you don't have this kind of tool to track if you're evolving correctly, it's just so easy to make a mistake and you only catch by the time you ship it, right? And it's just, there's nothing worse than having to do a point release of fixing an API you messed up yourself.
Yeah, and I mean, I think people understand deleting a method that's going to be bad, but there are more subtle things, where you thought that moving it to a base class is always safe, but it's not always. Like there are, for casts and so on. Right?
Or changing a constant, or adding a parameter,
or like even overrides. For example, you have an override that has a return type, and a return type has a nullability on there. Like, what can the parent method do in terms of changes to change that? Like, what are you going to break? And like a lot of it is you have to be like, okay, let me write it out in a long list of all possible cases. And even then, like, you might still make a mistake. And if a tool just does it, you don't have to think about it.
Yeah. Speaking of static analysis, I think the AndroidX team also does quite a few lint checks, right? Most of them, I think, are intended for external consumption. But do you have any sort of for your own workflow?
We do. I think there are certain things that we choose to impose on our own developers that we wouldn't want others to suffer from. Namely, suffer as in like do the work that is very painful and gives you smaller gains than you might want.
This is the classic don't use enums rule, I'm assuming.
Well, in this case, we don't have that, but we do have, for
you've
instance, in
written-
Compose, we have some checks for performance reasons that, they're micro optimizations. We're going to go through that pain, like Aurimas said, because we are the inner loop of the app. We're never going to ask an app to do the same thing. So, one thing I would tell to our listeners is that don't see everything we do as something you have to do, right? Like we do those things for ourselves and for you, but please ignore them. If you disagree with them, that's cool. We're okay with that. Nobody's arguing that you should be doing the same thing.
Yeah, I think we try to be very explicit of what we think is, for the developer and what we think we want to do ourselves. There's some stuff that we wrote for Lint as well that are very like our setup specific. So an example is we currently cannot put an @ignore on a test class at the top level. And that's purely because we have some silly decisions we made in our testing infrastructure. And like we wouldn't want everyone else to do this. But like for us, it's a bad idea. You have to annotate every single method. And so we just add a lint check. So like now if someone is an IDE typing, they're going to get a call out like, why did you put it on top level class, put it in a method? And then, even for this one, I don't think we have an autofix, but for a lot of things like that, we can actually even provide an autofix. So, it's control whatever, and then it goes and fixes it for you.
It seems like a reasonable one for everyone, right? Because I think, someone might not see it and go add a new test, not realizing this is implicitly ignored.
Hey, I
like
think
maybe,
that one.
Maybe that one should be default.
Yeah.
I don't know. Yeah.
Well, send us feedback if you want it to be part of the lint checks. We'll happily add it.
Yeah.
But yeah, no, there are lint checks, and it's very powerful that we're able to distinguish between the two, right? It's awesome that we can write lint checks that are just for us, because again, the way we write code is very specific to our projects, so that's nice.
Yeah, I think one nice thing is that AndroidX, having moved to open source and working entirely in EOSP, like you can go and like see what we've done, and oftentimes you can even click through and see why we've done it, because bugs or comments are out there for everyone. And in fact, you can see that people in the ecosystem are following our tracks, and we often get messages from companies like Slack where they also open source their Gradle plugin that they build on top of AGP and all the other things, and actually allows us to get inspired by each other. Mm-hmm. So an example, something that Slack recently did that we're like considering is they have classes of build machines. So you can use small, medium, or large. And if you have a very powerful machine, you can give Gradle way more RAM and you get, different set of benefits. You can get more workers and so on. But then there's some people, like Adam Powell on our team still running on the laptop of 8 gigabytes of RAM. We can default to that high number. So then it allows user to kind of choose like, am I on a small machine, medium, large? And that like allows us to kind of configure all of this stuff. We saw it in a Slack Gradle plugin. They open sourced it and we're like, oh, that's cool. Like, can we borrow and take the same thing and like adopt the same mechanism? And like that allows us to differentiate, someone working on a laptop versus someone working on like a cloud machine somewhere in the 72 cores, right? Like there's quite a bit of difference on performance characteristics.
Well, speaking of Slack open source, they also have written a bunch. I want to say like 80 custom lint checks as well. So, I can turn any conversation into a conversation about lint.
That's right.
You always do.
We should probably say I think we've agreed we're going to have an episode about it at some point, right?
Yes, it's going
back
to be a
to
very long and
AndroidX
boring episode.
and Gradle. What have we not talked about today that that's relevant to sort of Gradle workflows, AndroidX?
Yeah, I think one thing that not only we are a customer of Android Gradle plugin and give feedback there, we're in fact like we kind of alluded to this, but we work a lot with Gradle the company and then Kotlin Gradle plugin from JetBrains. And I think that gives us kind of like a next level of collaboration where I think us having used so many different plugins and having such a large project, it actually gives us opportunities to kind of like step back and be like, holistically, what is a good idea to do for that kind of problem? And then we're able to go and talk to Gradle and JetBrains and try to kind of discuss something that might make sense. So an example of something like that is currently when you're modifying build files, and this is something Tor is going to hate, is whenever plugin fails to configure in any way, we just fail the configuration, the sync phase in Studio. And we fail usually the stack exception in Gradle. And to the user, it's one of the like least friendly ways of telling them they did something wrong. You could have a typo, you could like mess something up along the way, you didn't save the file, many different ways of getting there. And so this is not the kind of thing that we could solve, not really a thing that AGP can easily solve, but it's something that needs like a broader kind of ecosystem decision. And so we had a discussion among the companies is like, what if there was a way for plugins to give back structured messages back to IDE to let you know that like you entered this value of like Java target 30 that doesn't exist yet. You can't do that, but then you continue configuring the project and then kind of pointing to a line of where you could go and make a change.
That would be amazing. Because, yes, I've seen a few of those sync issues where sometimes, if you look hard enough at the stack trace, you can figure it out. And sometimes...
Yeah, we had another sync summit again a few weeks ago. And this is one of the things that Gradle will be working on is basically provenance, right? Basically, any kind of value in the model attributing exactly where it came from. So it's going to. They think they can do it pretty cheaply, doing all this tracking, so that you can actually find out, like, oh, that came from a plugin or that came from this file. Because right now the IDE has a bunch of heuristics for helping you with a sync failure, but behind the scenes, it's grepping in the build.gradle trying to guess, right? Like, and this just isn't a proper way to do it. So.
And I think that's the kind of stuff where us and AGP and Gradle and Kotlin kind of collaborating, that's where you can come up these like, instead of each person solving that same problem and adding regex, adding like workarounds, adding like custom stuff, now we're able to do like a more, kind of holistic solution. And like, for example, the way we got motivated by this, we upgrade Android Gradle plugin for our kind of developers of AndroidX libraries. We want them to use the version of Studio that matches that version of Android Gradle plugin because we're using canaries, and there is no promise that canary to an alpha will match. And so we want to warn users if they sync the code and now they have new version of AGP, but they're still an old version of Studio because they haven't closed it. And so we fail sync right now. And then that's a really hammer solution is like, you shall close. And instead of we could maybe like pop a balloon saying like, oh, maybe you should consider restarting. Like that will work better. So that kind of stuff where we currently don't have a signal of saying like, hey, heads up. We can only say like, no, /hammer, like turn it off and start again. And now you're getting a new version of Studio.
Yeah, and just knowing what's going on, like, is so less frustrating than you feel like you're running into a bug and you're just, rebooting the machine and it fixed it. That sounds awesome. Get it done, Tor.
Working on it. We are trying to relax the tight coupling between Gradle and Studio. I want to say that's going into Iguana. We'll see.
Yeah, I think one thing I would note on that is actually one cool thing that Android Gradle plugin recently did is that they actually publish snapshot builds of AGP. So if you go to AndroidX.dev, you can actually go and find, by CL snapshots of Android Gradle plugin. So if you filed a bug, AGP has said they fixed it, you can actually go and try it out and make sure that it actually works for you.
We actually are now also posting nightly builds of Studio. So the same thing, when you fix a bug, if you're motivated, you can go and download the nightly. It is not like auto-updating with patching and so on, so it's not a thing. It's not a place you want to be on the nightly. But
it's a one-off type of validation.
Exactly. You want to either confirm or like, hey, I want to use Canary because I want StudioBot or something that's only Canary. But I'm blocked by this one bug, so I'm going to switch to nightly for a couple
It's better
days.
than waiting like 3 months and then realizing the bug wasn't actually fixed because...
Yeah.
It's never happened before.
Yeah. What is that? Trust but verify?
Yeah. No, never happened before.
Just as we started last month, if you have any questions about this...
And I'm sure you do because it's Gradle.
Yeah. Questions or suggestions or complaints or requests.
We don't need the complaints.
Yeah, send those to Romain. If you have any questions about this, go ahead and post them as comments on the YouTube version of this episode, and then we'll try to address them in the next episode.
All right. Anything else that we missed?
I think it's in a good spot.
That's a lot already. Yeah. And I'm sure there's a ton that we could keep talking about this, but yeah.
Yeah. No, thank you.
All right. Well, thanks a lot, Aurimas.
Yeah, thanks for inviting me. It's always fun to chat about Gradle, especially when Chet's now not here.
I agree.